The purpose of my experimental project was to find a way to reduce carbon dioxide levels in Earth's atmosphere by manipulating plant growth. The experiment compared the difference in plant growth between 3 specimens. One specimen was a plant under normal atmospheric conditions. The second specimen had carbon dioxide added to its atmosphere, and the third specimen had carbon dioxide and artificial light added to its atmosphere. The carbon dioxide and light source were used as catalysts for the photosynthesis process. In other words, they were used to try and speed up the plant growth process. Using this concept, we could reduce carbon dioxide levels in the atmosphere by increasing carbon dioxide consumption of agricultural crops in greenhouse enclosures. The purpose of the experiment was achieved and the hypothesis was supported. I got the idea of my project by creating a baseline of an innovation that could help a worldwide problem: carbon emissions. After researching what carbon does to other things, plants came up as a side idea. Researching what carbon does to plants, I realized that the photosynthesis process needed carbon dioxide and water to create sugar and oxygen to grow a plant. So I wondered, if I add more carbon dioxide to the photosynthesis equation, what will happen to the plant growing? How will it affect it? Negatively or positively? What if I could apply carbon dioxide that is harming our atmosphere into the equation as applied carbon dioxide to speed up the process of photosynthesis? I really wanted to know what could happen. So the idea of applying carbon dioxide to an enclosed environment to see if the plant grows faster became my project idea. The rest is history. While performing the experiment, we had some complications and problems, which required changes to the apparatus design. Mold was observed on the plants. This was determined to be caused by high moisture levels inside the greenhouse apparatus. I had been adding water daily to keep the plant alive and healthy. Little did I know the soils were too wet and caused moisture to evaporate in the enclosure. The high moisture levels in the enclosure fogged up the enclosure's walls, and one could clearly see huge water droplets on the floor and walls of all the enclosure, and on the plant's leaves. Not only that, the plant could not take in such moisture, and with too much water, it created a white fluffy mold that ate away at the roots to the leaves. A few things were changed to try and eliminate the mold. First, desiccant was added to the greenhouse apparatus for specimens 2 and specimen 3. This did not work. Second, specimen 1 and specimen 2 were moved away from the window. The weather was very cold at the time, and the thought was that cold air coming in contact with the greenhouse apparatus and specimen 1 was causing the condensation. This also did not solve the problem for specimen 2 and specimen 3. New desiccant was purchased and added to the greenhouse apparatus, in addition to the old desiccant. The combination of these changes resulted in no condensation being observed in the enclosures or on the plants. This also stopped the mold growth. This catalyzed photosynthesis process can be used to grow many different types of crops in Canada and around the world. Each crop type will probably have a different rate of CO2 consumption, but they will all help to reduce CO2 greenhouse gas emissions into the atmosphere. If this experimental process was used in real greenhouses to produce crops in Canada, how much of an impact could they have? I looked at 2 examples to see how many greenhouses would be needed. One was to reduce the same amount of CO2 that is emitted by road transportation like cars and trucks, and the other was to meet Canada's greenhouse gas emission target. After some calculations, we would need to have 21,323,839 hectares of greenhouses to remove all of the CO2 emissions from cars and trucks in Canada. Since Canada has 68,900,000 hectares of agricultural land, that means the greenhouses would have to cover 31% of all agricultural land in Canada. Therefore, we would need to have 46,507,760 hectares of greenhouses to reduce all of Canada's greenhouse gas emissions to a level that would meet Canada's 2030 carbon emission targets. Since Canada has 68,900,000 hectares of agricultural land, that means the greenhouses will have to cover 68% of all agricultural land in Canada. Based on the business plan I prepared, I believe it is possible that a business could be successful at providing these greenhouses to farmers. More research would be needed to see how much of an impact they would be on the cost of crops. Of course, the greenhouses would add cost to the farmers, but increased crop growth from the catalyst photosynthesis would also increase the amount of crops the farmer could sell. It probably doesn't make sense to have greenhouses covering 31% or 68% of Canada's agricultural land, since it would cost too much money. But using some of these greenhouses would help reduce carbon dioxide in the atmosphere and help Canada meet its carbon reduction goals. It will also help food grow faster, which is good for the people of Canada as well.